Unit 12, Day 3, we're going to talk about cylinders and cones and finding the surface area and volume. For the cylinder, we need the radius. Radius is given to us on our picture and it is 4 centimeters. Perimeter for a circle is circumference. And the formula for circumference is 2 times pi times radius. So that means 2 times pi times 4, which is 8 pi, which is approximately 25.13. So 25.13 centimeters. All right, to find the base area, the area of a circle is pi times radius squared. So that means it's pi times 4 squared. So in other words, 16 pi, but which is approximately 50.27. Centimeters squared. And our 3D height is 13.8 centimeters. Now we need the formulas for the lateral area and total area and the volume. So let's go to our chart. For lateral area, it's 2 times pi times radius times height. And for total, it's the lateral plus 2 times pi times radius squared. And then for our volume, it's base times height. So again, it was 2 times pi times radius times height for our lateral area. Total was 2 times pi times radius times height plus 2 pi r squared. And our volume was b times height. So for our lateral area, let's just make sure I wrote these right real quick. Yep, we're good. 2 times pi times radius times 3D height. So our radius is 4, our 3D height is 13.8. So this is approximately 2 times pi times 4 times 13.8. 346.83. Centimeters squared. So again, our total area is the area around a figure plus the two bases, right? So the area around is your lateral area plus 2 times your base, because pi r squared was used to calculate the base, b. So it's lateral area plus 2b. So we don't have to calculate it again. In other words, is what I'm trying to get you to notice. Some of these calculations have already been done. So we just need to transfer the information to this line. So it's 346.83 plus 2 times B, and B is about 50.27. And so I just need to add those together. Now I'll grab my calculator. So I'll take the area I just had found plus 2 times 50.27. And I get approximately 447.37. 447.37. Centimeters squared. And now for our volume, it's our base times our base area times our height. Our base area was 50.27. Our height was 13.8. 693.73. 693.73. Centimeters cubed. All right, on this cylinder, we're given our diameter. So to find our radius, we'll take our diameter divided by 2. So that would be 10 divided by 2, which is 5 centimeters. Again, and then you should be able to find the perimeter, aka circumference, the base area, and the height, as well as the other 3 on your own. Good luck. Finish it, please. Now let's get into cones. For cones, we need our radius. On this particular cone, we're given our diameter again. So to find our radius, we take our diameter divided by 2. So that's 40 divided by 2, which is 20 meters. We need our 3D height and we need our slant height. We're given our slant height, the 29 meters. But to find our 3D height, we need to use Pythagorean's theorem. The red line represents the 3D height. So that's what we don't know. We have our slant height, which is 29, and then our radius, which is 20, would be the bottom of our right triangle. So to find our slant height, the shortcut would be take c squared, which is 29, minus a squared, which is 20. And let's grab our calculator. And we get 21. So 21 meters is our 3D height. Now let's look at our formulas for cones. For a cone, the lateral area is pi radius slant height, and the total area is pi radius slant height plus pi radius squared. And then for our volume, it's 1/3 base times height. So let's write these down real quickly. So pi radius slant height, pi radius slant height plus pi radius squared, and then our volume was 1/3 base times height. So pi times our radius times our slant height. So our radius again was 20. Our slant height was 29. So let's multiply all of this together in our calculator. So that's approximately 1822.12. Meters squared. And for your total area, it's the same predicament. It's the lateral area plus one base because this figure only has one base. It doesn't have two bases. So I guess we should have found that in the beginning. I meant to add that line, and I'll do so in the future. I'm sorry. But that's 1822.12 plus pi times 20 squared, since we did not calculate it already. But that's fine, we can calculate it now. So we'll take this answer plus pi (20) squared. And you get 3078.76. 3078.76 meters squared. And now for our volume, we need 1/3 times B times H. Again, B is found by taking pi times 20 squared. And then our 3D height was 21. And now let's put it all in our calculator. One-third times pi times 20 squared times 21. And I get 8796.46. Ah, 0.46. 8796.46 meters cubed. All right, on this cone, our radius would be found by taking 70 divided by 2, which is 35 meters again. We're given our 3D height this time, it's 50 meters. So we need to find our slant height using the right triangle relationship. So it'd be 50 here, half of, and our radius at the bottom. So our slant height is C. So the shortcut is take 50 squared plus the square root of 50 squared plus 35 squared. Let's grab our calculator. And it's roughly 61.03. 61.03 meters. Let's go ahead and add our base area so we're prepared for this one already. Again, the base area is found by taking pi times radius squared. And it's roughly 3848.45. Meters squared. All right. The formulas again. Our pi radius slant height for lateral. Pi radius slant height plus pi radius squared for the total area. And volume is 1/3 BH. Okay, our radius was 35. Our slant height, 61.03. Let's grab our calculator. And we get 6710.60 meters squared. Again, the total area is the lateral area plus the base area, because there's only one base. So let's take our 6710.60, add our base, which was 3848.45. Grab our calculator and let it do the crunching. And we get roughly 10,559.05. 559.05 meters squared. And now for our volume, it's 1/3 base times height. Our base area again, 3848.45. Our 3D height is 50. Grab our calculator. Whew, another ginormous number. Alrighty, 64,140.83. 64,140.83 meters cubed. All right, so this concludes our notes for this lesson.